Okay, so when we start this Unit 2, we're going to continue studying derivatives. So this unit is basically memorizing a bunch of derivative rules. So we've already introduced one little shortcut rule, so this is going to continue that. So now we're going to learn rules for a bunch of different things. So if you're good at kind of memorizing and processing formulas, this is a unit you can excel in because that's all you're really doing, just memorizing a process. So again, we've talked about what a derivative is. We're really understanding the slope of a tangent line at a specific place. Okay, that's what we're doing when we figure out the derivative equation. The derivative equation will give us the slope at any specific point of time. So what is this used for mostly in real life? So if you're doing engineering stuff, you're going to get into this a lot. You're doing projectile objects often, and now if I derive it, I can figure out the velocity. So if you take a time height equation and you're deriving it, that's giving you a velocity. Okay, so we talked about the power rule already. So if we had y equals k with an x to an exponent, if we had an equation that looked like that, how would we derive it? So the derivative is going to be like this. Y prime is representing me doing a derivative. Okay, so what did we do again? We did the coefficient times the exponent. So I'm going to go kn, front times top, and then x to the 1 lower. Okay, so we've already done 2, we'll do 1 here. So if this is our equation, 20x7, then the derivative is, what's 20 times 7 without your calculator? What's 140. X to the 6, 1 lower.
That's just what we did last.
Yep, that's that one. Okay, sum or difference. So if you have an equation of a few things, I don't know, you might add this or subtract something, then when you derive it, it's just the derivatives. You just take the derivatives and just add them together. That looks way more complicated than it needs to be. We just figure out the derivatives. So what's an example? So here we go. So the derivative of this is 21 x to a 1 lower, 6. Before I derive that, I'm going to rewrite it. How would it look different? 1/2. Radicals are 1/2. So now if I times that, it would make a 4. And then 1 lower, -1/2. And you can leave it like that. Obviously, a different way would be writing 4 over root x. And what's the derivative of a number without x's? Nothing. Okay. Graphically, does this make sense? Like if you were to graph y equals 6, what does that look like again? Y equals 6, how do you graph it? Just a flat line, right? What's the slope of a flat line? 0. Which is why the derivative is 0, because the slope of a flat line is 0. Okay, here we go. Product rule.
How's that one different from the one?
What's that?
How's that one different? This one different from the top one?
It's not. It's just saying that if you have a few things, just do all the derivatives of them and put them together. That's all it's doing. Okay, here's something new now. The product rule. If you have a function times by another function. Okay, here you go. Ready? It's a little bit longer, so I'm going to give myself a little more space. I'm going to derive the first times original second plus original first derive second. So what do you have to do? You have to alternate deriving one of them times the original of the other. And it kind of matches our log rules. When there was timesing, we add, right? That kind of matches those log rules. Okay, so here we go. So I have two items. Okay, this is my first item. This is my second item. Okay, so look at my f bracket. Let's derive it. So 2x plus 8 times by the original g. So you see that, what I did? F prime times the g. Right? Plus the original first bracket times the derivative of the second one. Good? Okay. Oh, this one has 3 things. So I didn't show you 3 things, but what can you do? You would probably do the first with an original, right? Would that make sense? Derive 1, keep. Then what would you do on this next process? Keep. Let's go G derived. A keep. And then the next one would be keep, derive the third thing. So you just take turns deriving one of them, right? Okay, so here's what it would look like. 3x squared, original. Plus original derive original and then again original derive. How does that look? You can see I highlighted. I took turns deriving something. Okay, product rule. Good? Okay, quotient rule. If you have two things that are being divided. Okay, very similar to the products, but there's going to be one different kind of thing. So we're going to start the same way. We're going to derive times the keep. What do you think we're going to do instead of add? Subtract. Keep. Derive. That's a similar process. And now there's something different. You're going to divide by this function squared. The original function squared. Okay, you ready? Here's your example. Okay, derive this top, so 2x plus 7 times the keep bottom. Derive times the keep of the bottom, right? Good. Minus keep the top, derive the bottom, divide by the original bottom squared. Okay, I'm not looking for you to simplify that, because then you will be there for another hour. All right, last one is the chain rule. Okay, so this is what your original looks like. So why is there a u in here? It just means that I have more than x. I might have a few things, a binomial or something in there. So the u is representing a unit of stuff. So when we do this, we're going to go front times top, same idea, of u to the n minus 1. That was the same. And then we're going to attach the derivative of that unit. Okay, so here's what it's going to look like. Okay, here we go. Derivative of this. What's in front times the top. So there's just a 1 in the front times a 10. So 10 of those units to the 9th. 10 of those units to the 9th times, I need to do the derivative of that now. So 12x cubed plus a half x negative a half. Do you see the parts of the rule? You do the power rule, but you have to attach the unit derivative on it. Okay, before I derive this last one, I need to rewrite it. I'm going to go this to the exponent. How do you write that exponent? 8/5, like that. 8/5. Okay, here we go. Front times top, which is just 1 time, so 8/5 of those units to the one lower. 3/5, because you're going to have to do a whole 5/5 lower, times the derivative of the unit now. So 2x, bless you, plus 9. Okay, I have more, but we'll leave those for tomorrow. They explode in size there.